So I'm wondering now, what do we have? Well, first of all, step number one, we're going to identify a right angle triangle. I wonder whether you can see it, because what we have here is a slant height, not a vertical height. And in order to find the volume of a pyramid, we need the vertical perpendicular height, don't we? But these guys only gave us the slant height. So therefore, we're going to use this. Can you see that? Right angle triangle. Now, if they give us the slant height 22, that's no good to us. Have a look at this triangle here. See how I've got a cross? That's this length there. We can't use that because that's on an angle. It's leaning backwards. We need it vertical to the exact center of that pyramid. So let's move over to this triangle. See this one here? It's a right angle triangle. It happens to be the same triangle right in here. See the little orange symbol? Orange symbol, right angle, 90 degrees. Yeah, you know what that means. We're going to be using this now to actually work it out. So step number 2 of this is to work out what the base of this right angle triangle is. See here? We don't have the base. We can work that out. So let's work out the base, and then after that, we're going to use a particular theorem to work out the height right over here. But before we do that theorem, let's go back and work out this base right here. So what is the base? Let's take a closer look. Well, the clues are in the question. What do we have? Well, we have a base of this triangle across this way of 18 centimeters. The depth across that way is 11 centimeters. Now, how do we find that base? Well, you know what? Since that height goes to the exact center, the middle of the pyramid's base, this rectangular base right here, that's in the middle. That means that this 18 centimeters, all we have to do to find the middle is to halve it. Chop it in half. That's right. Cut it right in the middle. And if we cut it right in the middle, we'll have exactly this distance here, which is equivalent to, let me just move over, this distance there. It's the same dimension. That to that. Okay. So let's chop it in half. There's our 18. Let's chop it in half. Half of 18 is 9. Therefore, I can safely write up here, right there, 9 centimeters. You see that? That is that 9 centimeters. We chopped the 18. I'm just repeating myself again. Okay, now that we have the 9 centimeters, we have the hypotenuse. Notice hypotenuse? That's 22 centimeters. We can use which theorem to work this out? I'm sure many of you have already guessed. It's the Pythagoras' theorem. Let me write that up. Okay, I like that Pythagoras. I love that guy. He's so cool. We have this triangle here. Let's work it out. How does his theorem work? Well, we can work out this length by taking the hypotenuse squared and taking away another length. Yeah, so let's do that. So that's 22 squared, which is the hypotenuse. Take away 9 squared, which is the base length down there. And then all we have to do is square root that and we'll have the height. So let's do that. So in our calculator, 22 squared minus 9 squared equals, that's a grand total of 403. That's not the height, is it? Because we have to square root it, don't we? It couldn't be 403. It's too big. So let's square root both sides. So the height for this magnificent pyramid is, the square root of 403 is 20.1 centimeters. This is part 1. Stay tuned. I'm about to show you in part 2 how to complete and work out the volume for that pyramid right there. Hi guys, welcome back to part 2 of this 2-part series in working out the volume of a pyramid. Now this is the pyramid we're going for. Now if you remember from part 1, what did we do? We calculated what the vertical perpendicular height is, and here it is written up here. Height equals 20.1 centimeters. Now that we have that, it's 3 simple, straightforward steps. Step number 1, all we have to do is write up the formula. which is the formula for the volume of a pyramid. Step number 2 is to work out the area of the base, the bottom part of the pyramid, this across here. And it's quite easy because it's like a rectangle and they've given us the dimensions. And step number 3, the final step, is to drag and drop all the values into the formula and come up with the complete volume, which is the total space inside this solid. So let's do this now. Step number 1 is write up the formula for a volume of a pyramid. Volume equals 1/3 area of the base times the height. So let's have a look at what we have here. Now we're going to go to step number 2 and actually work out the area of the base. Now here's the base right there. Let's work it out. The dimensions are already given. It's 18 centimeters by 11 centimeters. So let's work out that area. Area of the base equals 18 times 11, which equals 18 times 11 on your calculator, grand total. Okay, that's 198 centimeters squared. That's the base right here, as you can see right there on the bottom of the pyramid. So now that we have the base, we also have the height from before. Let's drag and drop those values into the formula and calculate our pyramid's volume. So let me point out first where they all came from. So there's our height, and here's our area of the base, goes right in there. So let's plug and play right now. So volume equals 1/3 times area of the base times the height, 20.1. Let's put that all in the calculator. 1/3, or 1 divided by 3, times 198 times 20.1. Altogether, the complete volume of this yellow solid right here, all in total is